Dad, I looked up a picture of a real neuron and then a neural network diagram and they look identical.
Because one is literally inspired by the other. Neural networks are the closest thing we've built to how your brain actually works.
But my brain doesn't run on electricity and silicon.
Your brain actually does run on electricity. The signals are electrochemical, not digital, but the concept of connected nodes firing. Identical structure. A biological neuron receives signals from other neurons. If the combined signal is strong enough, it fires and passes the signal on.
And an artificial neuron does exactly the same thing?
Almost exactly. It takes inputs, multiplies each by a weight, adds them up, applies an activation function, basically a threshold, and passes on the result.
What's a weight? Like how important is each input?
Exactly right. A high weight means this input matters a lot. Low weight means nearly ignore it. The weights are what the network learns to set correctly. Now stack millions of these neurons in layers. First layer sees raw inputs, pixels, words. Each layer extracts something more abstract from the layer before.
So layer 1 sees edges, layer 2 sees shapes, layer 3 sees faces?
Exactly that hierarchy. Nobody programmed those layers to do that. The network figured out that hierarchy is useful, from seeing labeled examples.
The network invented its own internal language for seeing. That is genuinely wild.
That's what makes deep learning actually deep. More hidden layers. More abstraction. More power. Also, much harder to train. Let's do a cat detector. You feed it a photo. It comes out the other side as numbers, 0.97 probability cat, 0.03 probability not cat.
But at first it's terrible, right? It thinks everything is a cat.
Weights start random, so yes, it's basically guessing. It sees the correct answer, calculates how wrong it was, and nudges the weights to do better.
And it does that a million times until it stops being a disaster.
Billions of times, but yes. This process is called backpropagation. Error flows backward through the network, adjusting weights as it goes.
Why do you need GPUs for this? Can't a regular processor do it?
A CPU is like a genius who does one thing at a time. A GPU is like 10,000 decent workers all doing math simultaneously. Neural nets need the crowd.
So that's why NVIDIA is worth more than God right now.
NVIDIA makes the GPUs that train the models. They are the picks and shovels of the AI gold rush. We'll do a whole episode on that. There's a nasty problem called the vanishing gradient. In very deep networks, that error signal gets weaker and weaker as it flows backward.
Like whispering a message down a really long hallway?
Perfect analogy. The early layers never learn well because the feedback barely reaches them. Researchers spent years solving this problem.
And they solved it? Or we just have bad deep nets?
Mostly solved, through better activation functions and skip connections, essentially shortcut wires that let the signal jump layers. GPT works because of those fixes.
How many neurons does a real AI have versus my brain?
Your brain has about 86 billion neurons with 100 trillion connections. GPT-4 has roughly 1.8 trillion parameters. Different architecture, hard to compare directly.
So in raw numbers I'm still ahead. That's reassuring.
For now. Also, your brain runs on about 20 watts. GPT-4 runs on megawatts of server power. You're still more efficient.
Ha! My brain is more efficient and it smells bacon. AI can't smell bacon.
I'm going to put that on a bumper sticker. My brain smells bacon. So deep learning is neural networks with many layers, trained on massive data using GPUs, via backpropagation and gradient descent. That's the core.
And this fake brain tech is what ChatGPT is built on?
ChatGPT uses a specific architecture called a transformer, which we'll dig into next episode. But yes, neural networks all the way down.
Neural networks all the way down. That should be the series tagline.
Let's wrap up and save the LLMs for next time.